Example. So find the bounded by. Find the volume of the solid that was created by rotating a region bounded by, right? Bounded by. And then the functions y equals e to the minus x squared. Y equals 0, x equals 0, x equals 1. Y equals to 0, x equals to 0, and x equals to 1. About what? About y-axis. Y-axis. This is exactly the example I'm talking about. Solution. So, just summarizing, for the previous methods, if I'm revolving about y-axis, that should be the y case. Not for shell. For shell method, it will be dx, but we actually don't know which method to use. So dx, so I would do dx, I would do like this, dx for shell, dy for washer. And it's up to you, because we never even told you which method to use, and we're not going to tell you in general. You have to choose which method to use to do the job. Dx for shell and dy for washer. So, bless you. So step 1, sketch the 2D graph. Let's do that. I don't know the method yet, and it's up to you as a scientist to choose what's more convenient. For this case, one of the methods will be not realistic to do at all. I don't know how the function looks like, y equals e to the minus x squared, so I use technology to draw it. Technology gives me this. Technology gives me something like this roof, and then I have the cuts. Y equals to 0, that's, y equals to 0, that's the floor. X equals to 0, that's y-axis. X equals to 1, that's the next one more wall. Y equals to 0. And I got my area, like so. Here's the area, and now I can revolve in so many different ways. If I'm revolving about x-axis, it will be solid, no hollow pieces. Y-axis, solid, no hollow piece. I can revolve about this curve as well. I can revolve about something completely random over here, or even tilted. But they say I'm revolving about y-axis. Oh, that looks pretty simple. What's the problem here? I'm just gonna copy this whole thing. I don't even need the whole thing, just the pink thing. And put 2 circles so my eyes can believe that it is a 3D object. Here it is. See, very interesting. So I got the rotation about y-axis, so I would like to use dy. Now, if I'm using dy case, and that's why I don't want to claim it first, what is the problem? Who can notice? If I'm using dy case, yes. Your integral should be in terms of dy, and then what do you plug in? That's what you mean. Yeah. You plug in x equals. That's, yeah, correct. Good job. See, I saw the hand over there. No, I got what you meant. Yes, learning how to say it out loud mathematically is hard, but I definitely guessed what you mean. So I will have to solve for x. Note 1. Cannot solve for x to use dx case, which is case 1. I cannot solve for x. That's actually impossible. When we were working with improper integrals, we learned that it is impossible. E to the minus x squared. I cannot solve for x in real numbers. I have to use complex numbers there. Then I don't want to use the x case. That just makes sense. Then, if I want to use the y case, shell method steps in. Shell method, reverse the variable. That was the note number 1 over here. Use the method, use the shell method. Well, I thought it was obvious. Use this shell method when independent variable should be different from the axis of rotation. In this case, we have y-axis of rotation, but I want to use the x case. That's exactly what I mean. So I want to keep x, and we rotate about y. So we're gonna use shell method. Step 1, 2D picture. Step 2, choose the method before you rotate. Step 2, let's do here, note 2. Let's do step 2. I will use shell method. I would say thus. Yes, that's a good word, right? People who will ever take GRE exam, which are usually foreigners like us, TOEFL GRE exam, we must take them before we come to America. Thus, we have to learn all those phrases. Thus, in summary, therefore, and so on. So I like to use thus. Thus, I'm choosing shell method. Not to solve for x, because it's impossible. Then I will keep let's see. Is there a mistake or not? Did you know there's a mistake? That's actually a small typo here. But it's pretty important. Because it's a bit new material, I actually understand if you didn't notice the mistake. Or you don't pay attention because it's Friday. If I want to solve for x, which method do I use? X equals blah, 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 dy. Thank you. So change to the dy case. I don't want to use dy case. I want to use shell method now in order to keep dx case. Even though we rotate about y-axis. And that's where the shell method comes in. That's my idea. Yeah. Good job for catching the mistake, whoever did. And if you did, you should be brave enough to say it. Note 2. Do not draw a 3D picture for the shell method. Note 2. No 3D graph for shell. It's not a forbidden rule. You can do it if you want. But what I noticed when I was TAing as a graduate student, students make lots of mistakes when they do. Not in the graph, in the formula. So when they create a 3D graph, it messes up where the function is located. And I'll tell you in a second why. So if you don't draw the 3D graph for the shell method, it's actually better because you don't make a mistake anymore. I notice it works, so that's now I'm recommending it all the time. Step 3, we chose shell method. We know it's gonna be dx case. We can write down the formula. The formula is new, we just covered it last time. New formula for you to memorize. Who remembers? We had pi r squared minus pi r squared for washer. For shell, we do what? 2 pi r and h, the height, and then dx dy. Exactly. Integral we chose from a to b because we chose dx case. Here it is. And then 2 pi r h dx. 2 pi r was circumference. Circumference of the shell, h was the height, dx the width or depth, width of each shell. Each shell is like the shell of the onion. It's kind of rectangle for the onion as well, and then it has some depth in it or width. So 2 pi r times h dx from a to b. So dx is not necessarily the same color, let it be outside. Now, we also learned that both are functions. R is a function and H is a function. And that's where the tricky part comes in. You have to figure out how to complete the formula. Integration will be not very hard most of the time. But completing the formula is important. So, let's do it. The first challenge is integral from A to B. This is where your x is running from A to B. Can you guess what it is? Why it's not from -1 to 1? Here it is. X equals from -1. Because of the way we're creating the method. So you're right, just letting you know. The way we're creating this method, here it is. Look at the right. A and B are coming from 2D. Because when we have the bottle, the water bottle, the water bottle is located from A to B. Then we slice it and unfold it. Of course, the unfolding part makes it larger. It makes it twice more, I guess, because this is going to be only half. You're unfolding and the other half shows out on the back. We don't need that. We only need whatever was as a 2D picture when we unfold. So that's important, and that's why I do not recommend to have a 3D picture at all. I would erase it completely. I will keep it like so. And then I will mention this is y. Because A and B are coming from 2D picture. From 0 to 1. A and B are coming from 2D picture. That's the difference. That's the difference. In previous methods, we used the whole 3D object to describe the location. Now, 2 pi, do you want me to kick it out? I kind of would like to. 2 pi is a constant. Let's kick it out. Now you have r and h as the functions. R, you go now to the graph and look here. So, if you still, let me give you this, the interesting idea here. What is the R? When you unfold and you get all this rectangle and 2 pi r is the circumference and h is the height, r is only half of it. This is my r, or small r or big R, doesn't matter. So r will be matching with the function. Let me show you that. It's kind of interesting idea. This is very hard to explain, so can you pay attention right now, even if you like found something on the phone. This is hard to explain, so maybe pay attention right now. If my x is here, right in the middle, which is 0.5, the radius will be all this thing. No, actually, the other way around. Let's see, like so. This is a 3D object. Let me again sketch it just like this. The radius is where my x is located. So if I'm putting a point over here, 0.5, then the radius is 0.5. It does not depend on any function. It just depends on the location. If I'm putting point here, which is 0.7, then the radius is, say, 0.7. If I'm putting at the end, then the radius is 1. If I'm putting at the beginning, the radius is 0. If I'm putting here, the radius is small, the radius is big. Seems like radius is a function, but it exactly matches with the location of x. So instead of r, I will just put x. My r matched with x. It's not a constant. It's a function that depends on x. And in this case, it matched with x. That is not always the case. But right now, I don't want to confuse with other cases. So just be very clear. Usually, r is there your function x or y, because it literally depends on the location. Unlike in previous cases. In previous cases, which is here, nice comparison, we're talking about y-axis. R was the area between graphs. This is because how we're slicing it. We were slicing it, and the radius was depending on each slice, and that's the area between graphs. Now, R is literally location. Here it is. This is my R, or this is my R, or this is my R. So it's literally the function, unless there's a shift. When there's a shift, that's not the case. But we're going to have shift later. I think that's the hardest part to explain. Height is easier to understand. Height. Let's go back to height. How about h of x? H of x. Let's together look at this. Stare at this. What is the height of this 3D object? Well, you imagine it as 3D. The height of the object. If I'm putting x, it depends on x. If I'm putting x at 0.5 again, the height will be what? Yes, it's gonna, what? Okay, let me write down. E to the minus x squared, thank you. Minus y equals to 0. So in this case, it's just e to the minus x squared, but it's area between graphs. Area between graphs, area between graphs. So we're going to have top minus the bottom. Top is e to the minus x squared, bottom is 0. And this is your h. Your h is, in this case, top minus the bottom. In the dy case, right minus left. While r is the location. And location is just x or y for the other scenario. Dx, this is the hardest part. If you can build this, Integration usually is pretty simple. Let me summarize on this kind of interesting picture. What we have here is basically a drum, right, which you're playing music with. Here it is. This is a drum. It was created from this nice 2D shape, like so. This is a 2D shape we used. This is the axis of rotation. Let's again try to agree with what I just said. What if I'm wrong? So let's agree together that I make sense here. Height, bless you. The height, when you fix your x, height is area between two graphs. Here it is. Top minus the bottom, top minus the bottom. Does it make sense? That's visual. What about the radius? That's the one that doesn't make sense unless you really look at it carefully. The radius of this 3D object, the radius is definitely something like this, right? It's just half of the whole spherical thing, half of this rotation. But then how big the radius is. If I put my x here, it's this big. If I put my x here, it's this big. If I put my x here, it's this big. If I put x to the end, it's the biggest one. So it seems like wherever I put the x, it's just going to be x. Make sense? So if x 0.5, it's 0.5, and so on. So I just put the function x there. Yes?
Is there a time when the radius is never like x, or I guess y?
X, and y, but yes, they will be shifts. With a shift, it will be x minus 2 if it's shifted by 2 units, and so on. That will be pretty challenging to explain, but I do have YouTube video on that for that reason. That's a good question, thank you. What do you think? Okay. Let's finish integrating 2 pi from 0 to 1. Something like this you will have in your quiz today. Do you remember how to integrate this? Use up. Thank you. Someone remembers. How about everyone else? U is minus x squared. U is minus x squared. Du is minus negative 2x dx. Change limits of integration or don't change? I'll change, because that's what you're supposed to do. But to be honest, you can treat it as indefinite integral and then go back to the original variable. But let's change because it's not too hard. 0, if you plug into x, gives you 0, technically speaking, minus 0 squared. 1, if you plug in, gives you minus 1 squared, which is just minus 1. Bless you. So that's exam 1. Hopefully you remember any of this. 2 pi from 0, 0 stays 0, 1 becomes minus 1. Don't be bothered, it's from 0 minus 1. You can always flip the order by reversing it and making it negative. Now, it's e to the u, that was the whole point. And then, let's see what I have. I have 2x dx. So I'm going to solve for 2x dx over here. Then actually, I don't need this 2 anymore. And it's going to be, instead of 2, it will be what? Negative. Again, review u substitution if you didn't understand what I just did. 2x dx is minus du. And I have 2, and let me put another color. And I have 2x dx. That is minus du. Agree? Basic u substitution, very classical example. Finish integrating. You don't go back since we changed limits of integration. Minus pi e to the u bar 0 and minus 1. See, negative sign allows us actually to flip. It will be positive. Well, you always can flip. So actually it is just pi from minus 1 to 0 e to the u du. But I don't plan to use that. Just for you to know, you can always change limits of integration and then change the negative sign to positive or positive to negative in front of it. Minus pi e to the minus 1 minus pi e to the 0. Simplify. If I'm going to get a negative number right now, do you know it's wrong? Why? It's volume. So if I get negative number right now, I messed up. For example, in the previous example we had last class, which I left here as an exercise, I went to my office and actually decided to find the number. I typed it in Wolfram Alpha and the answer was negative. So I got concerned that I gave you example with negative volume. I was staring at it for 10 minutes, could not find a mistake. And I found it. There was like a constant missing in Wolfram Alpha. So your notes are perfect. But I did not put 6 there, and that one number made everything negative, so I know I messed up somewhere. And that's a good thing. It's nice as a scientist to know that you messed up. Minus pi e to the minus 1, you can check that it is true. It's easier to write down as pi minus pi over e. Is it positive or negative? What do you think? How do you know? Pi over e is less than pi. Pi divided by e probably is less than pi because e is a number, 2.7, blah, blah, blah. E is not, well, technically speaking, e is like 0 point something. That's not necessary. But e is bigger than 1. So that is the idea here. What do you think about that? What do you think about that? Yes?
Were you recording that?
Yes, I am recording, yes, everything. And if I forget to record, then I don't forget the next class. So that's good also. Not too bad. Shall we do another example or do the quiz?
Can you do an example from the quiz?
I cannot do example from the quiz. Quiz covers the improper integrals and stuff like that. I'm thinking to move shell method homework to be due Wednesday and show you more example on Monday instead. I think that will be better. I think it's too overwhelming right now to give more examples. So let's see.